Welcome back. This is the Tutor Wizard. I'm Adrian. Please subscribe right here. Hit the notification bell. You'll get notifications for this linear algebra series and a bunch of other ones on our channel. What we're doing today is linear algebra 1. Chapter 1 is systems of linear equations. Specifically, this lecture we're going to summarize solutions to one linear equation in one unknown variable. So this will be a one equation in one unknown recap. So to recap what we did last time, and if you don't want to watch the longer videos, here's the condensed version recapping what we did last time. We have notation for unknown variables, which are x, y, z, or when we get a whole bunch we're going to use indexing x1, x2, x3, etc. For constant things or fixed numbers in problems, but we generically have to call them a and b, and that's why you hate it. Those fixed constants are going to be a, b, c, or eventually you'll see we're going to use a11, a22, aij, etc. to double index stuff. A linear equation specifically in all contexts, but for right now one equation and one unknown. That's linear if every term is a constant, so one of these guys, or one of these guys times exactly one of these guys in every term. And again, a term is something separated by plus, minus, or the equals sign. Here's a couple quick examples. This is clearly linear. This is the most general form of a linear equation you'll see, in fact, because every term is either a constant, which we classically group together and put on the right hand side, or a multiple of a single variable, which we group together and put on the left hand side, and then you'll see how we solve for x. In this one, it's non-linear because this term is a constant term, this term is a constant term, this is -1 times a single variable x, but this is x times x is x squared, so that's a term which has the variable twice, and you can only have a single multiple of a variable, and so that's bad. This is the one that ruins it. And here cos is a nonlinear function, so that ruins it, and this is a nonlinear equation which has no solution because cos is stuck between -1 and 1, so he's never equal to. No solutions. Two solutions. One solution. We'll get to that. What's the solution? Before we do solutions, we're going to focus on linear equations. So the most general form of one equation and one unknown is ax equals b. And then we want to know what are the four cases. This is the crux of them, what we're going to use for the rest of when we use Gaussian-Jordan elimination. We're going to try and systematically use this scenario and the four cases that we get for solutions of this to answer all of the bigger systems. What do we mean by a solution to this equation? It's any real number x that we can find which makes this statement a true statement. In this scenario, you're going to see, yes, either there's going to be no solution, infinitely many solutions, or one solution. Let's see how we get that scenario on cases of A and B. That was nothing. Close enough. Remember, a solution to one equation and one unknown, because we only have one variable x, that's a solution is any real number x we can find which makes our equation true, whichever one we're given. And you hadn't thought about it because you probably in your brain immediately went to this scenario where a and b are both not 0, otherwise there's nothing much to talk about. And in some sense I see what your point was, but that you phrased it wrong because there's a whole bunch to talk about. Let's recap that quickly. If you have that a is 0 but b is not 0, what you end up getting is a times x is 0 times x, but that's always 0. So then we get 0 is equal to 0x, which is also equal to b because that's the equation we're given, but we know that b is not 0. And so that says 0 doesn't equal 0. And this is bad, and this is a logical contradiction, so may lightning strike you down. And this is our actual mathematical symbol for contradiction. And this means, long story short, no solution. If you get 0 equals non-zero, bad, no solution. We'll show you what that looks like in an augmented matrix in REF once we do Gaussian elimination later. Once we do case 2, what if they're both 0 now? That's going to give us something entirely different, like the opposite of this almost. Infinitely many solutions. Is infinity the opposite of nothing? Possibly. If I get this equation, this is a tautology. X is free to be any real number, so we're going to call it a free variable. You'll see why later, but we're going to call it somebody else. It's like, why did you make the move and call him t? Because he's now free to be any real number, and whatever number you put in there, t equals pi, is still true. 0 times pi is 0. 0 times e is 0. 0 times any real number is going to be 0. And what does that say? Because the cardinality of the real numbers is Aleph 1, which is strictly larger than the Aleph naught. And a lot of guys in here, long story short. So that's what we say, infinitely many solutions. This is why, because the real numbers has an infinite number of people in there, uncountably infinite. There's infinitely many solutions to an equation like this. This will be important later. If you get a row of zeros, in most cases, infinitely many solutions. Case 3, now what if A is not 0? Then we know that R has the property that any non-zero A has an inverse, which we call the reciprocal. I'm going to call the multiplicative inverse. Therefore, we can multiply both sides by that, and we get x is 0 over A, which is still 0 every time. Where did it go? Over here. 0 times 1 over A, still 0, because 1 over A is a real number too. And then we get 0. This says that we're going to get a unique solution, and that's why these ones are essentially the same, but we categorize them in 2 different cases based on the actual A and B's, and intellectually now we're going to have one more piece of terminology, trivial and non-trivial. Unfortunately, that means 0. So this is the unique 0 solution, which we call the trivial solution because it's not interesting, it's not going to give us information. And we have, in the other case, if they're both not 0, we can solve, and because B is not 0, B over A will not be 0, and we have a unique non-trivial solution. So you can see, even in this scenario, in the color coding, I had to color code the last 2 the same color because there's only ever no solution, infinitely many solutions, or a unique solution, either the trivial or the non-trivial one. Please subscribe right here, hit the notification bell. I'll see you next time.